Okay, the question was a physics one. Can a car going this way be hit by a car going this way, and this car end up facing this direction? The answer is yes. You have mass, inertia, energy. Mass and energy, in this case velocity, make up inertia. Okay? When you apply mass and energy and velocity, you have what's called a vector. So for example, this car going this way has a vector of this direction. This car going this way has a vector of this direction. Now when you combine two vectors of equal value, for example, 2 units this way, 2 units this way, will usually equal 2 units this way. A 45-degree split between the two units. But this assumes that the inertia of this car is equal to the inertia of this car, and that there's no other conditions involved in the accident. For example, if this car is massive and this car is tiny, the inertia could look more like this. While if this car is massive and this car is tiny, the new vector could look like this. Okay? Now, this again assumes a perfect bounce. That assumes the two cars hit, transfer all of their energy to the new vector, so this car ends up at 0, this car ends up at 0, and this vector ends up with 100% of the energy available. Okay. Now, you have other factors in play here. You have drag on this car, you have drag on this car. Those are going to alter the vectors. Drag is going to be associated with tire patch, road conditions, mass of the car, total inertia of the car. So the larger car with the larger tires is going to have a larger drag coefficient than the smaller car. That's going to alter all these variables. Then you have the last variable, the variable in the puzzle. They had to pull the cars apart. So what happens when this car sticks to this car, when they become attached? Well, now you no longer get a deflection vector. You now get a rotational vector, because one of the cars will act as an anchor and the other car will act as whatever direction you want the rotation to go. Okay? So, if you have an object anchored and I hit the object from this side, I'm going to get a rotational vector that goes this way. If I hit the object from this side, I'm going to get a rotational vector that goes this way. Anchor will be determined by several factors. The key factors here are drag coefficient, which is a factor of weight. This car is 2.5 to 3 times heavier than the Metro, assuming 1,700 pounds for the Metro, and assuming roughly 3,500 to 4,000 pounds for the car, which is pretty typical for your average American car. So you're going to have there's no question whatsoever. And then two other issues you have is that this car's drag vector is going to be amplified by the fact that you're trying to push the car against the rolling resistance of the wheels. The wheels want to go this way. So take a tire. If you push the tire this way, it's a lot easier than if you try to push the tire this way. So you have 4 tires on this car, heavier mass on this car, and a slower overall speed on this car, which is going to dramatically increase that car's drag coefficient. So this car, without question, is going to be the anchor. The Metro, once it becomes attached to this car, and in his description he said they had to pull the car apart, so they were attached. This car is going to become anchor. As we noticed here, we hit the car from the right. Think of the Metro as having impacted the car. Doesn't matter, relativity doesn't matter which way you go. I mean, whether this car hits that car, or this car hits that car. The point is, you have a vector this way, a vector this way. This car is heavier, this car is more drag. This car is going to act as an anchor. So when the two cars collide, if the Metro does not have enough inertia, enough energy to overcome the anchor of this car, it's going to create a rotational vector in the direction of the anchor, which is going to be left. So, heavy, high drag, slow moving car heading this way at a slow speed versus the Metro at a relatively higher speed, a lightweight, low drag on the ground, and no excess drag, because the tires are rolling in the direction they're supposed to roll, while the tires of this car are going to be trying to get forced to roll in the direction they don't want to go, the high drag direction. So this car has a lot of excess drag. When the two cars collide, the cars are going to end up going in this direction and this direction, because this car is going to act as an anchor. The only way the car would end up going this direction is if there was a deflection. No deflection, you have a rotation, so the car is going to turn this way. That's how your Metro ends up facing left. Any questions?